Welcome back. We talked about where magma comes from, kind of how it's created. So depending on where magma is created, what's going on will determine the type of magma, which determines what will occur, the type of volcano that's created, also the types of igneous rocks that are created. So there's three different kinds of magma. The first is basaltic magma. Basaltic magma has a low viscosity, meaning it flows very easily. It's flowy like water. And when this magma erupts, it forms very gentle eruptions. Andesitic magma, it's viscous, so sticky. Low viscosity, very runny. The higher the viscosity, the more sticky. So sticky, think syrupy sticky. A little bit more stickier than that, actually. But it's viscous. It's very sticky, slow-moving magma. When it does tend to erupt in volcanoes, it tends to erupt explosively. And then we have rhyolitic magma, extremely viscous, very, very sticky, very slow-moving, and erupts very violently. So think about it. If this is the surface of the Earth and you have some basaltic magma, it's very runny. When it gets to the surface, it just kind of flows out. It's very runny like water. It just kind of flows out to the surface. Whereas andesitic magma is very sticky. It moves very slowly, very slowly. It builds pressure. It builds up pressure. It moves so slow it's sticky. It builds up pressure until it erupts explosively. Rhyolitic, very sticky. It just builds up. Builds up and 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 wow, large eruptions. Oh my goodness. That was very animated of me, sorry. So, how do we distinguish between basaltic, andesitic, and rhyolitic magma? First off is by their composition. So anywhere from 45% to 75% of magma by weight is silicates or silica or quartz. So depending on how much or how little quartz is in the magma will determine what type of magma it is. How much water vapor and carbon dioxide are present. The more water vapor, the more carbon dioxide, that changes the chemistry of the magma a little bit. And then temperature. So lavas vary in temperature from a cool 650 degrees Celsius all the way up to 1,200 degrees Celsius when these things are at or near the surface. Magma with a higher water content melt at lower temperatures. So it goes again to the kind of chemical makeup of the magma. And then viscosity. So different magmas have different composition, they have different temperatures and different viscosity. Which is their ability to flow. So a low viscosity, very runny, high viscosity, very sticky. And again, that's influenced by silica content melted in the magma itself, quartz content. So again, viscosity is just the degree to which a substance resists flow. Just wanted to kind of separate this out since this is probably a new term for most people. A less viscosity liquid is very runny, whereas a high viscosity liquid is more thick. I know I always used to hear this word on oil commercials back in like the 80s and 90s. They're talking about their like motor oil is like a low viscosity, meaning it moves very, very nicely, very smoothly. So if you put this in your engine, things aren't going to grind. It's going to help things move very easily. So it has a very low viscosity for motor oil. Again, this depends on the silica content, SiO2, which is the chemical formula for quartz when it's cooled and hardened. We call it silica when it's melted in the magma. There you go, SiO2. So kind of putting that all together, here's a nice little chart. So basaltic magma ranges very low in silica, 45 to 55%, but it is high in some other minerals, iron, magnesium, calcium, low in potassium and sodium. And basaltic magma tends to be very hot, low viscosity, very runny, low gas content. Low gas content. So the more gas, the more explosive. The less gas, less explosive. So, in summary, basalt, very runny, not explosive. It's hot, just kind of oozes out onto the surface because it has low viscosity, and it's low in silica. Andesitic magma, 55 to 65% silica. Middle of the road temperature, 800 to 1,000 degrees Celsius. Intermediate, so a little more sticky. Gas content intermediate. The more sticky a magma is, the more gas is going to be trapped. And then you have rhyolitic magma, highest in silica, lowest in temperature, highest in viscosity, highest in gas content. So the most sticky, slowest moving, therefore it traps the most gas, therefore the most explosive. All of that is tied to silica. So the more silica, the slower it moves, the higher the viscosity, the more gas content. So again, where does this stuff come from? So basaltic magma, typically coming from mantle material due to not necessarily a wet melt, but more of a dry melt, melting because of a pressure release. So the basaltic material coming from lower in that interaction between the crust and the mantle. Not lower in the mantle, but where the crust and where the mantle is, kind of lower in that area where magma is formed, where you find basaltic magma. As you get a little bit closer to the surface, the melted material becomes more andesitic, and as you get even closer to the surface, that melted material becomes more rhyolitic. So basaltic magma is coming from a little bit deeper down, about 80 kilometers. Andesitic magma, around 40 to 60 kilometers. Rhyolitic magma, a little bit higher up. So you can also tie, so if you're looking at a volcano on Earth and it's emitting a bunch of basaltic magma, well, you know that stuff comes from deeper down, has a lower silica content, hotter in temperature, lower viscosity, low gas content. So it tells a story. So this is kind of where we're going next. But looking at the type of material and the type of magma, I should say. The type of magma from kind of a high temperature basaltic magma to a low temperature rhyolitic magma and kind of an intermediate andesitic magma. And also when that magma cools, what type of intrusive igneous rock forms. If that magma, hot molten material, makes its way to the surface and now known as lava, what kind of rocks do those make? So if we have basaltic magma, if it cools underground, it's known as rock gabbro. If it cools on the surface, it's known as basalt. Andesitic magma, if it cools below ground, then it creates a rock called diorite. If that material makes its way to the surface, it makes a rock called andesite. Rhyolitic magma, if it cools underground, forms a common rock called granite. If it cools above ground, it's rhyolite. There's an additional kind of in between these two we sometimes separate out, and this type of material would form granodiorite below ground, dacite above ground. It's kind of an in between viscosity, silica content between these two. But the magma chemistry, the composition, temperature, so all those characteristics, depending on where that melted material comes from, further down in the crust-mantle interaction, higher up in the crust-mantle interaction, will determine the type of rocks that are formed, also the type of volcanoes that are formed. Basalt is very runny, forms very gentle volcanoes. Andesite and dacite forms very steep, explosive volcanoes. Rhyolite's so sticky, it doesn't really form, mountainous volcanoes. They just have large explosions in relatively flat ground. So we'll talk more about volcanoes coming up, but this is just a quick introduction, as best it could be, to magma, its properties, why it's different, and what are some things that are created from this different composition. When we come back, we'll talk about how the different magma forms our different igneous rocks. See you back here in just a minute.